All right, kiddies, day 7, lunch review, focus, directrix, systems of 3 equations, and a couple of weird problems at the end. So, let's first talk about, let's talk about where you should find these documents so that you can print them yourself. Go to New York State Teachers, go to www.nkinfinity, that's Newman right there, that's the bald-headed you-know-me. Go to here, click on review, blah, 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 blah. Click on review topics way down here at the bottom, and we're talking about focus and directrix, and I'm cutting that video right now, so when that should be hopefully a live video for you, maybe it should be, if you're watching me, it should be. Just click on that, and you can print it. It's all yours, free of charge. Use it, abuse it, do whatever you need to do, all right? But get it out. Now, if you like what you're doing, please do me a favor. Hit the subscribe button. I've spent a lot of time working on this. You can do me a favor. You know, I spent a ton of time working on these things. You can do me a favor by just hitting that subscribe button. If it's not available, make sure you log into your Google account, and then you can hit subscribe button. But that helps me out, and hopefully I'm helping you out. And if you really like the material, send a text message to your friends. Send a tweet, Snapchat, whatever you have to do. Get it out there. Because, you know, I always find, invariably, I will find next Thursday night kids desperate looking for things. And they go, oh my God, I finally found your channel. Get it out there, kids. Let other kids know, hey, this guy's pretty good. He can help you out. Okay, that's all I'm doing this for. It's Friday night at 9 o'clock at night. I gotta love you guys and love what I'm doing in order to do this, because otherwise it's a little crazy to be doing it. And I got some coffee. Okay, so focus directrix. Let's talk real quick about focus directrix. I want to make sure you guys whoa. Let's back up the crazy train. That was the other video. Let's go over here and talk. A focus directrix definition of a parabola is, given a parabola and you have a vertex, you can define a parabola by a focus, which will be up here, and a directrix, which will be down here. Now the key feature is any point, x comma y on the parabola is equal distance to the directrix and to the focus. And that's important because it's including this vertex. This distance, whatever this distance is going to be the same as this distance. Now I should probably call this distance 1 and distance 1 and distance 2 because they're a little bit different, right? But the vertex is halfway between the directrix and the focus. Now I'm going to show you how to use your calculator to help you out with this. By the way, it could also be upside down. I could have a parabola that looks like this, and my focus here, or my directrix there, and my focus there. The focus is always on the inside of the parabola, and the directrix is always a line either above or below that. So that's the main idea of focus and directrix. So let's talk about how to solve these suckers. All right, let's get going. Now, there's a couple of different ways. I'm going to do these problems 2 different ways. I'm going to do it the easy way, and I'm going to do it the slightly harder way. The easy way is not to distribute that 8, but to divide by that 8. And divide by that 8. And so why am I doing that? Well, over here I end up with y plus 3 is equal to, now remember, there's really a 1 here, right? So what I have is 1/8 x plus 4 squared. Now after I do the next step, I'm hoping you notice something. I'm going to subtract this 3 over, and I get y equals 1/8 x plus 4 squared minus 3. Well, do you recognize this as vertex form of a parabola? I hope so, because the vertex is sitting right here. The vertex is -4, +3. There it is. So, if I wanted to, without technology, I could come over here and go like this. All right, my vertex is -4, -4, -3, -4, -3. And by the way, the better thing to do is go to that piece of graph paper at the back, but you're going to have to show your work, so I actually show it here anyway. -4, -3. That's my vertex. I know my directrix is down here at -5. Directrix at y equals -5. And because, now remember, the vertex is halfway in between. So remember, this distance is 2. So all I got to do is go up 1, 2, and I should be able to find the focus. Well, that would be at -4, -1. And that's the answer to this question. And that's as simple as it gets. Now, how can I do it using my calculator? Okay, let's go over to graph mode. For those of you that have this calculator, and I hope many of you do, we'll type in control division 1/8 parenthesis x plus 4 parentheses squared minus 3. There it is. There's the parabola. Well, if I go into menu, analyze the graph, analyze the conics, and I choose Directrix, I click on this. Oh, that tells me that I have the right Directrix. Oh, let's go menu, analyze graph, analyze conics, and I go to focus. This foci or focus or whatever the hell they call it. Click on that, and there it is, 4,1, -4,1. Now, if you use your graphing calculator, I would use it as a check, but you can also use it as a, you can write down, I use my TI Inspire and the Analyze Conics section. Now, how would I do this else? I told you I was going to do it a couple different ways. The other way I could have done it, for those of you that are distributors, by the way, you should be doing these problems before I do these problems. But let's say you're a distributor. You do 8y plus 24 equals x squared plus 8x plus 16. All I did was double distribute this and distribute this. So I get 8y equals x squared plus 8x minus 8. Divide by 8. Divide by 8, divide by 8, divide by 8. And I say, okay, y is equal to 1/8 x squared plus x minus 1. And now I graph that. I can do the same thing, come over here and graph that. And it's going to be 1 divided by 8x. I'm going to do this a little bit faster way. X plus x minus 1. Boom, there it is. Same graph, and then I can do a menu. I can do a couple things. I can analyze the graph. I can find the minimum. Click, click, there's the minimum. Found the vertex. So I didn't really need to get it in vertex form. I can do it like this. And then I can say, okay, menu, analyze graph, analyze conics, focus. Boom, click on it. 4, -1. -4, -1. So that's another way I could have done it. All right, so if you didn't get that one, try this one on your own. Hit the pause button, try this one on your own. I'm going to do it the easy way. So hopefully you pause it. Now you're back. Okay, good. Thanks for coming back. I'm going to divide by -12 and divide by -12. And I'm going to get y minus 5 equals -1/12 x minus 6 squared. Then I'm going to bring the 5 over, and I get y equals -1/12 x minus 6 plus 5. That means my vertex is at 6, 5. All right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. There's my Directrix. How far away is it? It's 8. It's 3 away. So that means I got to come 3 down. So that was the point 6, 5. If I come 3 down, isn't that 6, 2? At least I think it is. So what I'm going to do is go over to my calculator. I'm going to use my calculator as a check. Tab. I'm just going to change this one. It's negative 1/12. Oh, I can't do that. Shoot. Parenthesis x minus 6 parenthesis squared and then plus 5. I'm going to use that. There it is. Oh, look. Still even kept the focus. There's 6, 2. Now, just to check, I'm going to go menu. I want to make sure I got this graph right. Menu, analyze graph, analyze conics, and I'm going to go Directrix, and I'm going to click on that. But I can't see the Directrix because I gotta change this. So let me come up here. Wait, hold on. There it is. Just change that. There's the y. All I did was grab this and move it a little bit. Click and hold. You can drag it all you want. There it is. Y equals 8. All right, done with that. All right, let's go to some other ways to do these problems. This says derive the equation. I'm not going to give you the equation. You got to derive the equation. All right, so here we go. You got to come up with your own point. And I'm going to use the point x comma y. Now remember what I said. If it's true, then these two distances have to be the same. So your goal is to find the two distances. My first distance is going to be between this point and the directrix. Well, that's just the y minus this. Y minus -1, which is really y plus 1. And my second distance is going to be between the point and the focus. So the square root of x minus -5, which is really x plus 5 squared, plus y plus 4 squared, really my minus -4 squared. Now, if this is truly a focused directrix, or if this is really, if I want to derive it, I got to set those two distances equal to each other. I got to set y plus 1 equal to x plus 5 squared plus y plus 4 squared. Now, in order to get rid of these, in order to get rid of that radical, I'm going to have to come over here and square this side and square this side. So on the left, I'm just going to double distribute that out. I get y squared plus 2y plus 1. If you're not good at double distributing, write it twice and really show your work. On this side, we're going to double with the square root, and that thing cancels, so I end up with x squared plus 10x plus 25. That thing double distributed. Now I'm going to double distribute that thing, which is y squared plus 8y plus 16. All right, here we go. The y squareds are going to cancel. They always do. We're going to bring this over by subtracting 8y, and I'm going to subtract this 1 over here. So I get -6y equals x squared plus 10x plus 40. Now I'm going to come through and divide by -6. Divide each piece by -6. Don't do this divide the whole side. Divide each piece by -6. If you want to reduce, reduce. If you don't, don't. I'm going to because I think it looks sharper. -1/6 x squared. If you put this in your calculator, it will tell you it's 5/3. Minus 5/3 x minus 20/3. Now I think that's the right answer. I think that's the right answer. I'm going to use my graphing calculator to really make sure that it's correct. So I'm going to type that in. -1/6 x squared minus 5/3 x minus 5 divided by 3 x minus 20 divided by 3. Holy crap, what is this? Okay, I'm going to click and hold, move that. Going to move this. Oh, it's all right there for me, right? You see it there? Do I have the right... Wow, that's weird. Do I have the right focus? I do. Am I still recording? Because something's off. Something weird's going on. Hopefully we're good. There's the focus. There's the directrix. Now again, if it's not there, you just go menu, analyze graph, go into analyze conics, click on focus. You click on it. Boom. There it is. -5, -4. But notice the directrix and the focus are exactly what were in the problem. So we're good. Well, I just had to reboot. So let's try this again. Anyway, this problem's slightly different, and that's because of this right here. And that's because I'm telling you that the directrix is the x-axis. And you need to know the equation for the x-axis is really y equals 0. So my directrix is really y equals 0. So we're going to do the same work. We're going to pick our point x comma y. And we're going to do the same distances. Well, our first distance is going to be between y and the y value. Or in other words, y minus 0, which is really just y. So that's my first distance. My second distance is going to be, remember, between the point and the focus. So square root x minus 2 squared plus y minus 4 squared. Set these two distances equal to each other. So y is equal to x minus 2 squared plus y minus 4 squared. Now, you're going to square both sides. So on the left, we're going to get y squared is equal to x squared minus 4x plus 4 plus y squared minus 8y plus 16. Now the y squareds cancel, but remember I want to have a y by itself, so I'm going to move this over here. 8y equals x squared minus 4x plus 20. Divide by 8, divide by 8, divide by 8, divide by 8, and it appears my equation is y equals 1/8 x squared minus 1/2 x plus 5/2, looks like. So I want to test that. I still need to use my calculator. I want to test it using my calculator. So come over to my calculator, go into graph mode, and what we got? 1/8, 1 divided by 8x squared minus 1 divided by 2x plus 5 divided by 2. Enter. Now, got to go into Analyze Graph. So Menu, Analyze Graph, Analyze Conics. We'll do Directrix first. Click on this. Notice, look what it says. It says it's the y equals 0 or the x-axis. There it is right there. Do it again. Menu, Analyze Graph, Analyze Conics, Focus. And we'll click on that, and it says that the focus is 2, 4. And that was the directions that were given in the problem, so we know we're good. All right. Let's start with a new problem. Find the equation in the form of y equals ax squared plus bx plus c that satisfies this point, or these 3 points. So the first thing we need to understand about these kind of problems is I gave you 3 points. These 3 points satisfy this equation right here. In other words, I can plug this point into this equation and it should work. So we're going to do that. 10 equals, now remember the 10 goes in for y and this goes in and the 3 goes in for x. So it's a times 3 squared plus b times 3 plus c. Or 10 equals 9a plus 3b plus c. There's our first equation. Now I'm going to plug the second point in. Negative 17 equals a times negative 6 squared plus b times negative 6 plus c. Or negative 17 equals 36a minus 6b plus c. Second equation. Now we'll do the third equation. Negative 2 equals a times 9 squared plus b times 9 plus c. Or negative 2 equals 81a plus 9b plus c. Now here's what I tell my kids to do. Stop, put your pen down, and use your graphing calculator to solve these 3. These can be solved on the TI-84, but I don't remember how. And they can be solved on the TI-Nspire. So I'm going to do that real quick. We're going to solve those on the TI-Nspire. So on the TI-Nspire, you go into your calculator mode. You go Menu, Algebra, Solve a System of Equations, Solve a Linear System of Equations. We have three equations. Hit the Tab button to go back and forth. A, comma, B, comma, C. Don't use X, Y, Z because that's what's not in our equation. Click OK. Now we got to type the equations in exactly as they appear. I'll put this right here. Oops. I'm going to put this exactly as they appear. So 10 equals 9a plus 3b plus c. Negative 17 equals 36a minus 6b plus c. Negative 2 equals 81a plus 9b plus c. Now make sure you typed them in correctly, hit enter. If you end up with some really screwball answers there, you're probably wrong. We're going to test it, though. I got a way to test it. So now I know what my answer is. Off to the side, I'm going to write A equals 1/3, B equals 2, C equals 7. I think that's it. Oh, it's negative 1/3. Be careful. So my equation, because the question is, what's the equation? My equation is negative 1/3 x squared plus 2x plus 7. Okay. I want to know if that's right. Okay, before I even go on, I'm going to go test it. So I'm going to go graph. I'm going to go into graph mode, and I'm going to graph that. Negative 1 divided by 3 x squared plus 2x plus 7 plus 2x plus 7. Press enter. Now, I can't tell if they're there, but I can go menu. I can go Control T, and I'm going to go check to see if those points are in there. The first point was negative 617. There it is. The next one would be 310. There it is, 310. And the next one is 9, negative 2. There it is. So since all 3 points are in that table, I know that I have the right answer. Now I have to algebraically get there because the work says show this algebraically. It should say algebraically. Here's how I do it, kids, and I hope you follow this for these kind of problems. I'm going to take this center equation, and I'm going to multiply it by negative 1, and I'm going to put it together with that one, and I'm going to put it together with that one. So 10 equals 9a plus 3, what in the heck is that? 3b plus c. Remember, I'm multiplying this whole thing by negative 1. So 17 is equal to negative 36a plus 6b minus c. Now the reason I do that is because it's very easy to get rid of c. So I get 27 is equal to negative 27 plus 9b. So now I'm going to do the same thing with these two equations now. I'm going to recopy the negative 2 equals 81a plus 9b plus c. And I'm going to take this same changed equation and use it again. 17 equals negative 36a plus 6b minus c. And again, the c's cancel, and I end up with 15 equals 45a plus 15b. So now I got to line these two up. And I got a trick on this one, actually. 27 equals negative 27 plus 9b. And 15 equals 45. Should be 27a. Sorry, kids. A plus 15b. Now, if I didn't notice this trick, I would have to multiply this first equation by 15 and the second equation by 9, because that would give me, what is that? Negative 135, or positive 135 and negative 135. But I noticed something, and I hope you noticed it too. And that is this equation right here. I can divide everything through by 9. So if I divide both sides by 9, I don't know where my mouse pointer went. If I divide both sides by 9, I end up with 3 equals negative 3a plus b. If I divide this one by 15, because everything can be divided by 15, I get 1 equals 3a plus b. Well, notice what happens. These go away, and I end up with 4 equals 2b, or b equals 2. And isn't that what we wanted? Ka-ching! Oh, here we go. My computer's screwing up again. All right, so now that I have b, what I'm going to do is I'm going to take b and I'm going to stuff it back into one of these equations. So 15 is equal to 45a plus 15 times 2. I could have put it back in this equation. It would have been just as easy, but it doesn't matter. This is 30, so I'll subtract 30. I'll subtract 30. I get negative 15 equals 45a. Divide by 45. divide by 45. And if you put that in your calculator or you use your brain, you'll see that that's a equals negative 1/3. Check mark number 2. Now what I got to do is I got to come back to my originals. And what I want to do is I want to find the original with the most positives. And since this is all positives, I'm going to use that equation. And I'm going to put that equation over here in purple. 10 is equal to 9a times negative 1/3 plus 3 times b, which is 2, plus c. I'm hoping I come out with 7. So 10 is equal to negative 3 plus 6 plus c. This is really just 3, so 10 equals 3 plus c. Subtract 3, and I get c equals 7. Good done. All right, that's it. That's that one. Now, how does it look if I just give them to you like this? By the way, if you want more examples like these, there's plenty of them if you go over to nk infinity. Oops, lost. If you go over to nk infinity, and I can't tell you exactly which ones because I don't know exactly, but if you go in here to review, and you go down here to my spiral reviews, of which there are plenty, there's probably 4 or 5 spirals in there that all have those kind of problems in there, these kind of problems in there. So you can go get some more reviewed in there. All right, so what are we going to do with this kind of a problem? Well, most kids want to start right away, jump right in, start working on the problem. That's not me. That's not what I want you to do. What I want you to do is I want you to find the answers first. X equals, Y equals, and Z equals. I'm going to go find the answers. Now, this is great because they already gave us the 2 equations. So that's what we're going to do. We're going to go find the answers. So let's see. I'm going to move this over here. Bring back my calculator. Go into calculator mode. Menu, algebra. Solve a system of equations, solve some linear equations. We got 3. And the good news now is we are using x, y, and z. We'll just leave that. So put this here. Negative 2x plus 5y minus 2z equals negative 17. 5x minus 2y plus 3z equals 13. Now, when you do this and you end up with some really screwball answers, you're probably wrong. If you do it, you end up with some nice answers, you're probably right. But triple check what you type in. You know how easy it is to make a mistake typing this stuff in? I think I got it right. And it looks like I got some nice numbers. 2, negative 3, negative 1. 2, negative 3, negative 1. All right, so how am I going to get these? Well, we're going to do the same process. It really doesn't matter in this case which one it's not like the other one, which was easy to get rid of C's. It doesn't really matter. I'm going to get rid of X's. So I'm going to put these 2 together. So I have to multiply this one by 2 and this one by 5. Because wouldn't that give me negative 10 and positive 10? Absolutely. So negative 10x plus 25y minus 10z equals negative 85. Remember, we're multiplying 5 by everything. And then I'm going to get 10x minus 4y plus 6z equals 26. These go. 25 minus 4 is 21y. Negative 10 and 6 is negative 4z. And negative 85 minus 25, it's too late in the night. I'm going to just do this. 25 minus 26 minus 85. Negative 59. So negative 59. All right, so we did those 2. Now I'm going to do these 2. But I got to get rid of x again. So in this case, I'm going to multiply this one by 5 and this one by 3, because that would give me 15 here and negative 15 here. So 15x minus 6y plus 9z equals 39. Negative 15x minus 15y minus 20z equals 35. Add these up, and I get negative 21y minus 11z equals 474. So now I got to line these suckers up. So I'm going to bring this one over here. Oh, this is really cool. You got to be kidding me. It can't be that easy. Minus 21y minus 11z. Oh, here goes my calculator again. God bless it. What's going on today? All right, kids. I think it might be time for a new computer. Things are messing up all the time now. Oh, come on. Just erase. All right, so we got this lined up. Minus 21 minus 11z equals 74. These cancel, so I didn't have to do any extra work. Minus 15z is equal to 74 minus 59. 74 minus 59. 15. So I divide, I get z equals negative 1. I hope that's right. Good. Now I'm going to plug this back into this equation. So negative 21y. I could have plugged it back into this equation. It really doesn't matter. Minus 11 times negative 1 equals 74. Negative 21y e plus 11 equals 74. I'm going to subtract 11. I get negative 21. Y equals 63, or y equals negative 3. Yes! Now I'm going to take the most positive equation. I guess that's this one. I love dealing with positives. 5 times x minus 2 times negative 3 plus 3 times negative 1 equals 13. All I did was plug in my z, plug in my y. So I get 5x plus 6 minus 3 equals 13. This is 3, so I'm going to subtract 3 because that's positive 3. Subtract 3, I get 5x equals 10, or x equals 2. Ka-ching! All right, kids, let's talk about some weird problems. Now, if you haven't tried this one on your own, please, please, please pause the video. Stop watching the monkey perform. But if you can't do it, watch it and then try this one on your own. It's a little bit different, but try it. Oh, this is a weird problem. Oh. Actually, they're not the same. I thought they were the same. So pause it, try it, see what you come up with. All right, you're back. Lovely. Okay, first thing you probably should do is get rid of these parentheses. So we're going to triple distribute this, and we're going to triple distribute this. All right, so this side doesn't change. 3x cubed plus 7x squared minus x plus 18 equals 3x cubed plus hx squared plus 5x plus 9x squared plus 3hx plus 15 plus k. Woo! That was a lot of work. Now what? All right. Well, the first thing I see is I got these cubes on the same side. They can just go away. By the way, it doesn't say prove, so I can just do whatever I want. Now, do you see what you got to do? Do you see that this is a squared term? Now, if these sides are going to be equal, I better have the same number of squareds on this side. Well, over here I got h squared and 9x squared. Those two things better be the same as that. Oh, do you mean 7x squared has to equal hx squared plus 9x squared? Subtract 9x squared, I get negative 2x squared equals hx squared. Well, doesn't that mean if I divide both sides by x squared, doesn't that mean h has to be negative 2? Yeah, we got it. Now, I'll do it in a different color. Let's do it in green. See, this is a constant. See these two? These two are both constants as well. So doesn't that mean that 18 has to equal 15 plus k? In other words, k has to equal 3. Now, there was this. Check this out. I'm going to do this in blue. There's the x term. There's an x term. And there's an h with an x term. So I know that negative x has to equal 5x plus 3hx. Okay, I'll subtract this 5x. I get negative 6x equals 3hx. Divide this side by 3x. Divide this side by 3x. Cancel, negative 2 equals h again. Now, I cannot stress this enough. Children, listen to me very carefully. Check everything. Check, 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 check everything. Now, watch what I'm going to do here. Watch what I'm going to do here. I'm going to take my red pen, and I'm going to say this is no longer this. It's now negative 2. This is no longer this. It's now 3, because that's what I came up with. And I'm going to use my graphing calculator tool to make sure I'm right. If you don't do this, you are a tool. So don't do a tool. So let's go into graphing calculator mode. And my first equation is 3x cubed plus 7x squared minus x plus 18. I don't care what that looks like. Oh, that's hard to look at. I'm going to go menu, window zoom, zoom fit. Let's see if I can get a better. There we go. That's what it looks like. All right. Now, if the other one's going to look like that, it better match it exactly. So I'm going to press tab, parenthesis. I'm going to type it in exactly as it appears. X plus 3. Make sure you do this. Otherwise, you might get it right. You might have it right, but you typed it in wrong. 3x squared minus 2x plus 5, parenthesis, plus 3. Did you see how it went right over it? Right? If I get rid of this, back in, right on top of it. If it doesn't, let's say you accidentally found this was a 4. You go, oh, okay. Oh, well, that one's hard to that one's hard to tell. But let's say you said this was a positive 2. How about that? Let's say you accidentally came up with positive 2. You got that one right. See how it's not exactly? See how it's off a little bit? And that's a great test to see if you got it right. All right, one more. Algebraically determine all roots. Well, we got an issue. We got this b here. So what we're going to do is we're going to figure out what b is using this. Remember, this is my y value, or my p of 2, and this is my x value. So 90 is equal to 6 times negative 2 cubed plus b times x squared minus 43 times negative 2 plus 120. Now, I hope you notice this is all numbers, and these are all numbers. So I'm going to type that stuff into my calculator. 6 parenthesis negative 2 parenthesis cubed minus 43 times negative 2 plus 120. Enter. Now, I might have done that a different way, but 158. So I get 90 is equal to bx squared plus 158. I feel like I didn't do that problem right. I don't know what I'm thinking about, kids. Hold on a second. So what I forgot to do is I forgot to put in the negative 2 here. So this ends up being 90 equals, what do we call it with? I did a little bit of work on my calculator. 90 equals 158 plus, remember, negative 2 squared is 4, plus 4 b. So I'll subtract 158. So 90 minus 158. 90 minus 158 equals negative 68. So negative 68 equals 4b. Divide by 4. Divide by 4. And I get b equals, divided by 4. My brain's not working. Negative 17. So what do I have now? I now know what b is. So p of x is really equal to 6x cubed minus 17b minus 43x, oh, not minus 17b, minus 17x squared minus 43x plus 120. Now, I want all of the roots or zeros. At this time, I'm going to get the answers. I want the answers right now. I also want to check, and I'm going to use this as a check to make sure that negative 17 is right, because if it's right, 3 better be in my list of answers. So I'm going to come over here, and I'm going to use menu 331. Menu, in this case, I got to do something different. Menu, polytools, find the roots of a polynomial. It's a third degree polynomial. Click OK. 6, negative 17. 6, negative 17, negative 43, and 120. And 3 better be an answer. 3 is an answer. Okay, good. So those are my answers. I'm done. No, wait a second. I'm not done. My answers are negative 8 over 3, 5 over 2, and 3. Now remember, 3 should have been an answer because of this right here, right? Remember the remainder theorem? But, it said algebraically. So you're not allowed to do this, even though I have the right answers. And now I'm at 2 points. This is a 4-point question. Now I'm at 2 points. Now I got to do the hard work. I'm going to divide. Now, since, here we go. Since 3 is a root, that means x minus 3 is a factor. In other words, I need to divide this by x minus 3. And that stems right here from this being a root. Therefore, this is a factor. Okay? So we're going to divide. 6x squared goes here. 6x squared minus 18x squared. This should be 6x cubed. Excuse me. We're going to subtract, add, and I end up with x squared minus 43x. I guess it's just plus 1, or plus x plus 1x. X squared minus 3x. We're going to subtract. I end up with negative 40x plus 120. Multiply by negative 40, negative 40x minus 120. We're going to subtract, plus, and you better end up with 0. If this is a factor, then you have to end up with 0 as your remainder. All right, we're almost done. The only thing we got left to do is to factor this thing. Now, the nice thing is, I already know what the answers are. They're right here. X equals negative 8 over 2 over 3. And x equals 5 over 2. Now, because this 3 and 2 are in the denominator, I know it's going to be 3x and 2x. Because this is negative 8, this has to be positive 8. And this has to be negative 5. Now, you could check it. There's 6x squared. Minus 15 and plus 16, isn't that plus 1x? And then negative 8 and negative 5 make negative 40. And there are my answers. Please do me a favor, hit the subscribe button, hit the like button. Keep practicing. Keep practicing. This is not an easy test. There's lots of work to do. I hope you have my flashcards. Make sure your friends have my flashcards. Make your friends know more about the website. All this stuff's on it. Download the materials. I'm hoping to have some more materials next week. I'm not sure about videos because there's only a finite amount of time in the day. All right, kids. Catch you all on the flip side. Goodbye.